Hi everyone, it's September 12th. Alright, let's get to it. UTF-8 validation. Given an integer array data. Okay, integer array data. Return whether it is a valid UTF-8 encoding. Character UTF-8 can be from 1 to 4 bytes. Subjected to the following rules. For a 1-byte character, the first bit must be 0. For an n-byte character, the first n bits are all ones. The n plus 1 bit is 0. Wait, hold a second. For n bytes character, the first n bits are all ones. As in these two, right? The n plus 1, the third bit, is a 0, followed by n minus 1 bytes, with the most significant 2 bits being 1, 0. Okay, makes sense now. X, should be like, there we go. That makes more sense if you do it this way. X denotes a bit in the binary form and of a byte that may be either 0 or 1. Yeah, that makes sense. 2 bytes, so I have 2 bit. 3 bytes have 3 bits. 4 bytes have 4 bits, followed by a 0, and the rest starts 1, 0. The input is an array of integers. Only the least significant 8 bits of each integer is used to store the data. It means each integer represents only 1 byte of data. So what you're saying is the input is an array of integers, and each integer is of 8 bits. Wait, hold on. Only the least significant 8 bits of each integer is used. So we only take the last 8 bits, only 1 byte of data. So what we're trying to do? It is a valid encoding. Okay, let's take a look. So what it's saying is 197. We're going to take the last 8. 1, 2, 3, 4, 5, 6, 7, 8. 255. So yeah, with only 8 bits. For 2 bytes character followed by a 1 byte character. So the first one, if it starts with 0, right? If it starts 0, then we can ignore it. If it doesn't start with 0, we need to count how many bits there are that are ones. And we count it, then we need to go for this minus 1 to see if they're all 1, 0. If they are, then that is also valid. See, like this one saying we have 3 1 bit, so it has to be a 3 bytes. Now we have 1 byte, 2 bytes is good, but the third byte has to be a 1 0 instead of a 0 0. Okay, yeah, this is not a difficult one. I don't know. It has a lot of people downvoting it, which I suppose is because I don't know, it has some weird edge case. I wish I'd cheer if they have weird edge case. It's kind of a test if we can identify all of them. But what I think is there's some edge case we just didn't realize. But we can try, or maybe just times out all of them. Yeah, that could also be a problem. But we're gonna go one by one. All right, we're gonna go one by one. Might as well to test. Oh, and at most n bytes. Holy crap. So at most is 1, 2, 3, 4, 5, 6, 7. At most is 7 bytes. So which means if we have a 255, that's going to be false, right? I need to confirm. So if I do a 255, this is going to be false no matter what. Well, this one's going to be false anyway, so that's not even a question. It's going to be false. Because it has to be. First n bits are all ones. So at the most, and n plus 1, we have to have n plus 1. Right? N plus 1 has to be 0. How do we count the number of ones as fast as we can? And the first one cannot be 1, 0, right? Because first one cannot be 1, 0, it just cannot be. If the first one is 0, then we just jump to the next one. Okay, let's do it this way. For D in data, right? And B equals bin D. That's from the second one, right? 0, 1, 2, yeah. And say if B0 is equal to 0, then continue. That's this case. Oh, we're gonna have to do, holy crap. Gotta be a better way to make this work. So I think what I need to do is check the first one, right? And if it's this, we move on, and if it's not, we check how many, and then we just group those. So I think I'm gonna do def validate low and high indices and binary str. This will give me a Boolean value, right? Ooh, do I even need low and high? Yes, I do. I actually don't have binary str. I need to have the data. Might as well just define it inside. Right? So we just want to see if low to high gives us a valid thing, right? So okay, the low I should already done, right? So what I need to do is n equals a line data. Okay, it's not low to high. Yeah, low to high is fine. So everyone has to be starting from 1, 0. Yes, that's basically what it is. So say if high is larger or equal to n, that's gonna return false. Right. Otherwise, I'm gonna say for D in for I in range low to high plus 1, it has to be 1, 0. The first two has to be 1, 0. For I in this data I, I'm gonna say binary data I, right? 2 to 4, 2, 3, right? Equal to 1, 0. All of them have to be this. I'm going to return as a validate. Okay, so if that's 0, now for ID enumerate data. Right, if cannot do this. I equals 0, while I is smaller than n, b equals data I, right? And if b is 0, then if b is not equal to 0, then we do something, and then, hold on. B equal to 0, I plus equal 1, right? We just simply ignore this one. Else, so it's not 0, then we need to count how many 1s there are, right? Then we say count, 1 count. Maybe there's a better way. Maybe we can strip. Right? Can we strip? Say b equals bin 197, 2 to the end. Right, b is this. So b dot left strip. Should remove all the ones, because this how we can just use the minus, right? So yeah, 1 count shall equal to len b, right? Minus len b dot left strip. So we'll get rid of all the ones. So they give me 1 count. Now we say if, because it has to be 1 followed by 0. So we say if, so I have this number applies, so 1, 2, 3, 4. So if 1 count is smaller than len b, right? If 1 count is smaller than len b, let's say, because the 1 count is the index of the next one, right? That's the index of the next one. So this is smaller than b, and what? B, 1 count is equal to 0. If these two is, then we can call validate. Validate what? Validate I plus 1, right? I plus 1 to I plus 1 count. We need that many, right? So if we do here, I plus 1, plus 2, I plus 3. Oh, well, we're including this, so it's actually not. It's I plus 1 and I plus, so like this one, count is 2, right? So I plus 1, and then this one should be minus 1. So when we validate this, everyone has to start with 1, 0. So we just say, if this, and this, if these three, then I equals, I plus equal to 1 count. Because I go I plus 1 all the way to I plus 1 count minus 1. So these are the, right, so it would be plus this. Else, if anyone, then we're going to return false. We'll keep going, then we return true at the end. Okay, that's the current solution. Let's see. This one is true. This one's false. I'm pretty sure there will be some hideous, edge case that I haven't considered. But high. Oh, I didn't do high. I did. Where? Oh, self dot. No, there's no self. It's opposite. Yo, man, the hell. It didn't make any sense. Let's print and the data I, and then B, and then one count. One count is 2, right? Which does pass, and now we should go to 1. Go to 1. Oh, we can now do bean. Ah, shoot. I can never remember how that's done. I think it's, damn it. 197 08B. Oh, I think that's the thing. Yeah, 08B. So if data I 08B. Right. Yep. Oh, this time I think it is right. Oh, the second one. The second one. 3. Oh, it's the same thing. There we go. Oh, oh, what? You kidding me, right? That is so fun. Which one? This one is... Oh! Yeah, yes, you gotta be kidding me. 2, 0 to 2. There we go. All right. Test case. We need lots of test case. So, what we can do is to generate lots of test case. So we can generate, let's say, 100. 0 to 255. Yeah, this one should be right. I think this one's right. Okay, we generate test case. So let me say from random import randint. And then simply do what? For test in, say tests equals this for this in range. Let's do, let's say 50. Okay, do 50 test cases. Each one is going to be randint 0 to 255. Okay, for this range 50. Test in tests. It's going to print test. Lots of test. Lots of test. But yeah, it's going to fail no matter what. Okay, let's do this. See. All of them are false. There's no true. We can, oh, that's just too much work. All right, let's try this. Didn't work, then just didn't work. We did this. What? 145. Expected false. How did I get it to be true? That is very interesting. What's 145? We start, so one count is 1, right? This one's true, so we'll validate I plus 1. It should be largely equal to n. I plus 1 minus 1. Ooh, there's a logical issue here. plus 1 count. Oh, 1 0 does not exist. Oh, holy crap. Holy crap. It cannot be 1. It has at least be 2, right? So if it's 1 smaller, has to be larger than, right? Has to be larger than 1. It cannot be 1 because this is 1. I see. Okay, so basically I have to add one more. How about this one? Oh. How? I have... Man. These are good test cases. Completely floored me. 145 again. What? The hell? Huh? Wait, what? One, two, three, four, five. 1, 2, 3, 4, 5. Okay. I see. Wait, hold on. What's that? No, that's not how it works. I forgot how to remove this, but it's okay. So we have this. And you're telling me this is not right? For 1 byte, this is not a 1 byte. M byte, let's say 1, 2, 3, 4, 5 bytes. The first M bytes are all 1. So the first 5 bits. Wait. Hold on. Are we saying we can only allow 4 bytes? Try it out. No, it's true. 1, 2, 3, 4, 5, right? And then everything is 1, 0, 1, 0. Alright, I don't understand. There's something that was missing. I think it cannot be longer than 4. That's the only thing I can think that might break it. Yeah, no, I think the most is 4 bytes. So it has to be 5. right? It has to be 5. Like only, so 2, 3, 4. They say 2, 3, 4. Yeah. I think that's the thing. And I think that's why people don't like this question. All right, so we have done that. Yep, exactly. That's exactly the reason. That's exactly the reason. And also why people don't like this problem. Completely understand. Completely understand. So it's not difficult, but two tricky things. One, a single 1, 0 1, 0 cannot be a leading byte, because for a value of only 1 byte, it has to start with 0. 2, each UTF-8 character, right, must not be more than 4 bytes. That's it. That's the two things that really caught me off guard. Yeah, so it's not a difficult one. It's just understand. Yeah. Oh, I explained this. 5 bytes. Can be 1 to 4. You didn't say that, right? Did you say that? Can be 1 to 4 bytes long? Oh, okay. It was on me. It was on me. I didn't read that. Okay, I did not read that. Maybe they added it later. Who knows? Yeah, I'm not doing bit manipulation for this. Why? It's all right. All right, so that's that. Yeah, I'm happy with what it says. So today is number 800. Oh, I was going to say 801, but actually I think it's 802. All right, 802. So give it a thought. I don't think I have any got to do this, but let's take a look what this problem is. It's just some new problem I want to try. 4 integers are x, y, s, and t. If it is possible to convert the point this to the point this through some operations or false otherwise. The allowed operations on some point x is to convert either x plus y, or x plus y, y. Source and termination. Start and termination, I don't know. Series move 1, 1, 2, 3, 2. Ooh. Very interesting problem. Simple. Usually these simple problems go to the extremes, right? Sometimes they're extremely difficult, sometimes extremely easy. This is a very simple problem to understand, but I kind of think maybe it has some graphic kind of solution to it. So we have x and we have y. And each time, either we keep x the same, right? And extend y to it. Or we keep y the same. And, now this is the keep y the same, extend x. Or we keep x the same and extend y. And are they all positive? They're all positive, so we're only talking about the first quadrant. So either here or here, right? That's the first kind of thing. And then we can keep, if we keep x the same, then we can extend, then x and y, then it actually becomes bigger and bigger. Holy crap. Well, we can only go up or go. So for one thing, right? Because everything is positive, that's actually simplified the thing. And it reminds me of one of the problems we saw in the past. We cannot go beyond. All right. If the txty is not upper right towards the upper right of x y, that is not possible. Like if tx is smaller than x, it's not possible because we either keep x the same or we increase x by y, which means we keep moving right. So that will be a very easy first check to see tx must be larger than x and the ty must be larger or equal to sy. That's the first thing. So now we have got that out of the way. So the starting point must be to the lower left. That's the end point, right? So we can kind of see from the starting point, let's say sx, and the end point is tx. We have the amount we move. So tx minus sx is the amount we have to move, right? So the amount moving right. And the same thing, we have ty minus sy is the amount we have to move upwards. And to move to the right, the only way to do is do x plus y, right? Now is this question, can we do, so we have to do an x plus y no matter what. But we can first do increase the y, and then, but at the end of the day, it's only going to be certain step going up and a certain step going right. But here's the trick. Here's the difficult part. If you do up first, if you do up right, and you do right up, the result is different. Okay, example, if we do up and right, we do up, we get x plus y, right? Now we do a right, we get x plus y, and x plus y. So that's up right. If we do right and up, what we have is x plus y, y. Let's go right first. Then we go up. That's x plus y plus y. See, it's different, right? That's very different. So by changing the order, then you have very different result. Now, the order can be arbitrary, and we want to see if these order, when they combine together, can become tx minus sx and then ty minus sy. Yeah, and it's order dependent. It's order dependent. Gosh. Let's think about this way. We have an end point, right? Then to reach the end point, in the last step, think about the last step. The last step either go right or go up. That's the only way to achieve it, which means if we have tx, ty as the last step, as the destination, then the last step must be, if we go right, which means we don't change y, so it's going to be ty, and then what's going to be the x. So we have, let's say, we don't know what, right? So it's going to be this, that time x plus y plus ty must be equals to tx. So it's either tx minus ty horizontally going to tx and ty, right? Because you add them together, or it's going to be tx doesn't change. Then we have ty minus tx, right? tx, ty minus tx. Then we go up, right? And that's go up. So you add them together, that becomes ty. Okay. Then what? Then what's the difference from this and the difference from the other? I mean, we can say we can go two-directional BFS, but I honestly don't see the point of doing this. And what we can do is, yeah, you just create 2 more points for us to reach, right? You can create lots of points as we go through, tons of them, right? At each one we can just extend and extend. Yeah, so we create these points, and then from the other side we also create points, and we simply just go, right? So these kind of go down, go left and go down, and then we go up and go right. Oh man. It does reduce the number. I agree. It reduces the number if we do bidirectional BFS. It does reduce, but the thing is, every single step we go this, right? Every step we go this, we go down, right? We go this, and then we go this. Okay, we'll have to do this way, right? This, so far is this and this, so we go this, and this. Every step. We go this. That will create tons and tons of points in space. That can be 10 to the 9th, right? So we can populate lots and lots of points. Especially if some point is small. If you look at this, tx minus ty. So if tx is huge, ty is small. tx is huge, ty is small. Then tx minus ty will remain huge. But ty minus tx will become negative. That's an interesting point. In fact, if we look at this, right, 3 and 5, it is guaranteed that it does not go left. And indeed, 1, 1, 2, 1, 2 is go right. Alright? No, let's go up. Let's go up and go right. Go up and go right, and then go up. Right? Go up, right, and up. So we cannot go left from tx ty because that would become negative. So, So on one direction, at most there, like for each tx ty, right? There's only one way. Well, there's only one way to go. Right? This one cannot go left, so it has to go down. Right? Think about it. We're at 1, 2, 3, 1, 2, 3, 4, 5 out here, right? If we go left, then require tx minus 5. 3 minus 5 is negative 2, which is impossible, so we cannot go. So we can only go down, which is 3 and 2, right? 3 and 2. So we have to go down here. So now we have 3 and 2. Then we cannot go down anymore because 2 minus 3 is negative, so we can only go left, which become what? X minus 1. So 1, 2. 1 and 2. Right? Now we have 1 and 2. We cannot go left. We can only go down, which becomes 1, 1. Holy crap! What we just discovered is this problem can be solved from txty, go back to xxxy, because every single time we can only go one step. We can only go one direction. It is not possible to go two directions. And you see this is larger than 1. So even if tx and ty, actually if tx ty is equal to 0, then we're doomed. Unless, of course, unless they're the same to begin with. Otherwise, we're doomed. Oh, very interesting. Very, very interesting. So we go backwards. Let's try. Let's see if it works. We still have time, right? We are at 42 minutes, so we might be able to solve this seriously. Now, this will be a big achievement. I'll be very happy if we can solve this. Plus, we're only asking a true or false question. So, well, actually, well, true. Because I can say if sx equal to tx and sy equals ty, return true. Otherwise, right? Otherwise, if tx equal to ty, return false. Like duh, because you just can't do anything. Because the next step will be 0, right? Then we say if tx is larger than ty, if tx is larger than ty, then tx will equal to, actually minus equal to ty, else ty minus equal to tx. And then we keep going, and while tx large equal to 0 and ty large equal to 0. Actually, I'm going to break. And now we'll return false here. All right, let's see. 1135, right? 1135. This is true. I should remember the test case. These pass. Test case. I need lots and lots of test case. So 1 to this. Randint. Okay, so for in range, I don't know, let's do 100 test case. So what's the formula? Holy crap. Print randint 1 to, nah, that's ridiculous. M equals 10. Okay, so 100 print randint 1 to M print for this in range 4 print randint 1 to M. Yup. Stupid as it is, these are test cases. Try it. Not a single true. Actually, we can do or tx is smaller than sx, or ty is smaller than sy. Okay, so what do we say? We say make this one smaller. There's a higher chance that we're gonna hit some good values. Actually, let's make sure that it will kind of work, right? So print randint, say 1 to 50. Okay, so we print 2 of these, and we print randint. I don't know, let's make sure, so 50 to 100. How about this? 50 to 100. Can I guarantee it won't fail? Just, you know, from the very start. Try this. Not a single true. Shoot. Let's just try it. I'm curious. Interesting. Either wrong or we had. Holy crap. The heck? I think we are right. It's just too slow. It's just too slow. That's what it is. Too freaking slow. Man, this test case is evil. Evil as hell. Because I have to go all the way down. Oh, every time only -1. God damn. We need to do it faster. Like, if you think about what you're doing, you just minus this, and then minus this, minus this, minus this, right? So we want to find how many, let's say for tx, how many ty can I minus? You know, as much as I can, without it become, yeah, this is basically what it is, right? So tx is larger than ty, so I say tx minus ty. That's the next tx, right? So for this, we're going to do tx, they're going to minus ty again. Because when I do tx minus ty, because tx is larger than ty, ty is not going to change. So it's just every time with the minus ty. So I just need to find out how many ty I can minus. So this means we're going to do div mod tx and ty. So this will tell me tx equals to q times ty plus r, right? Which means I can do this, which means I can do if this, then tx shall equal to tx mod ty. Right? That's the remaining. That's the remaining. If it's divisible, then we'll just keep going, but then we might miss a point because at this time, every time we have to check. Holy crap. So we have to do this at a point before it hits Sx. So we're going to minus ty until a point where it has to be bigger. So what I can do, let's say we do tx plus Sx. How about this? Which means we'll minus however much I have. I don't like it. I think what I want is I want a remainder that's bigger than Sx. How do I make sure the remainder is bigger than Sx? And what I can do is, tx is larger than Sx, right? Tx has to be, because if tx is smaller, then it's wrong. So what I can do is tx, right, then plus tx. So we guarantee that the value is larger. Otherwise, ty equal to ty mod tx plus ty. Then we run this. Cannot assign. Oh, my bad. It's plus sign. No way. I think this one's hitting a different problem. What the hell is the problem now? That's a different problem. Pretty sure. Hold on. 1, 1. Oh, this is evil test case. Okay. We handle evil test case. Actually, I don't even know if it's true or false. Put a none. I have no idea. But my current solution is to do this. And this one's giving me, I think I probably hit an endless. Oh yeah, I can see why, but I want to confirm. Let me just comment out these. Tx and ty. That's 0. Holy crap. No. That should not be tx. Shall be ty. Right? Yeah, why is tx, man? It should be ty. It shall be the minimum number of ty at that time needed to make it larger than sx, right? So I always say it's, because I have to be larger than sx, right? So we can do sx divided by ty, current ty, and then say if I need this much to make it, then we do this plus 1 times ty. And this will be sy divided by tx plus 1 times tx. So basically what I'm saying is I will reduce as many ty as possible, but I need to make sure what's left of tx is larger than sx. And how do I make sure of that? I need to, because I can do as many as I can, right? This is just the remainder, but I need to add more ty. But how many ty I need to add? This is how many more ty I need to add. So I run this. I think that's an infinite loop as well. So we go to 2, 1, and we got stuck. Got freaking stuck. Oh well, I mean, we can say temp is this, because 2, that's 0, plus sx is 1, divided by 1 is 1, 1 plus 1 is 2, so it's 2. So which means we do this, nothing changed. So we say if tx is temp, right? So if temp is equal to x tx, which means x tx doesn't change, then tx minus equal to ty, which is simply just minus equal to. Else, again, same thing. Then we say temp equal to this. If temp equal to ty, which means it doesn't really change anything, then ty will minus equal to tx. Oh, you gotta be kidding me. What? I thought we go down to... Wait, what? How? Oh, I forgot else. Shoot. Tx equal to temp. There we go. How about now? Huh? How about now, you evil? That's true. That's true, baby. That is true. Let's try the others. I have high faith in this. Come on. Come on. Get this. Get this. Get it. Get it. Get it. I don't think so. Let's probably hit an infinite loop. That probably hit an infinite loop. That's okay. That's totally fine. We just go see where did we go wrong. That's okay. Perfectly okay. These type of things happen all the time. Yep, we just bump back and forth, back and forth. This probably didn't even reach high 153. Yeah, that's the third one. Jeez. Jeez, man. No way. It gets bigger. Holy crap. So I should say if temp is larger equal to yeah, didn't realize it can actually get bigger. Yep, false. Okay, try it again. Come on. Come on. Yes. Yes. Got this one. It's a good problem. Very interesting. Very interesting problem. The breakthrough was that was the realization that we should, right? Should go from tx, ty backwards. This is because from tx, ty, there is always only one way to go. Either to tx minus ty, right? Tx minus ty, or tx, ty minus tx, depending on whether tx larger than ty or ty smaller than tx, respectively. Know that if tx is equal to ty, it is most likely a dead end, unless it happens at the very beginning and sx equal to stx equal to sy equal to ty. Now the difficulty is to realize that we should not just do tx minus equal to ty or ty minus equals to tx at each step, right? At each step, because that is super slow. We should use mod to remove as many ty from tx or tx from ty. However, we also must not remove too much, right? Such that we miss sx, sy. Thus, my strategy is to remove as many as possible, then replenish the smallest amount to tx or ty such that the new tx or ty is larger than sx or sy. Of course, there are a few small errors during implementation, but they will be fixed. They can be fixed rather easily. So yeah, that's that. I don't know. What is the runtime? I mean, each one will only do once or twice, because I just divide it. I take as many as I can, I take them away, right? And then we do it again, and then I don't know the runtime, but I just know this. Let's see. Yeah, it's a good question. Very, very good problem. back to front. Modulo from the end, yes. Log, this is a log. So keep this going as far as we can. What if it becomes 0? This becomes 0 as well. So it's guaranteed, right? So sy smaller or equal to ty. What if ty is smaller than sy? Because ty, like in this case, the both become 0. Because tx is like 10 to the 9th. 10 to the 9th becomes 0. This, ty is still big. Ty is still giant. So in this case, we do this, but this one doesn't fit. How does this work? Very curious. I don't think I'm going to change my solution because I really like it. But I'm just generally curious of how this one will work. Like literally. This case, right? It's txty this time. Tx didn't change. What? I'm more surprised by this result. It should be 0. Oh, smaller. Smaller. Huh. Okay. So if they come out, because every single time. Because if the reverse, if something is smaller, it will remain the same. Gotcha. That's actually a good observation. So we do this every single time, which you guaranteed we'll only do this, right? So we'll go as many as we can, and we'll hit a value. So what if we hit a value? Make Sx is larger than Tx. And we're simply saying it's not possible. This is the last step. I can see this is the last step. So it's not the last step, just like the last one we can go. Makes sense. This is how much more we have. And every single time we'll reduce Tx because the y didn't change. So we just minus Tx minus Sx minus this, minus this, minus this, minus this. Okay, that makes sense. So my question is, if this one doesn't result into it being this way, so we just keep going, keep going. What if one of them becomes smaller? Then just saying it's impossible. Well, it is, right? So every single step is either stay the same or the other one will be minus this. Other one will be minus this, minus this. Keep minusing, because that's the only step we can take. So if it really goes beyond, then there's no going back. And doesn't make sense, right? Holy crap. It's actually very good. Yeah, going backwards. It's like now you're answering their question. Yeah, indeed. This is the amazing part. Okay, so copy. I'm not sure if no, I am sure I will never be able to figure this out like that. So that's that. I mean, I don't have to do it exactly the same, but very inspired, right? Say inspired by a very neat trick is to is that if a smaller than b, a mod b equal to a. Thus, we don't have to compare tx and ty before modding. We'll still do all this. Then we just say tx ty equal to tx ty mod tx, right? And then say while x is smaller than tx, sy is smaller than ty, and we'll simply do this, right? Another important observation is that if tx mod ty is smaller than sx, then it is impossible. If throughout the tx operation the remainder is smaller than t, then it is impossible to end up at Sx. Right? Because we will overshoot it no matter what. Okay, then we shall return Sx equal to Tx and Sy. So one of them reach first, right? Sy must be smaller or equal to Ty and Ty minus Sy. Right? The amount we need to go, because Sx equal to Tx, so we can only go along the y direction, and every time we do that, we will minus x. So it has to be Sx equal to 0. Actually, we can do Tx or Sy equal to Ty and Sx smaller equal to Tx and Tx minus Sx mod Ty equal to 0. Once the while loop exits, for the Tx, if Tx is equal to Sx, then Ty, then we must have then we must have Sx equal to Tx and Sy smaller equal to Ty, or Sy equal to Ty and Sx smaller equal to Tx for it to work. In either case, we can either move vertically down or horizontally left Tx at a time, Ty at a time. Hence, we must check Ty minus Sy mod Tx or Tx minus Sx mod Ty. It's brilliant. Boom. Yeah, not sure if it's going to be faster. Maybe not. We shall see. Oh. Log. Beautiful solution. All right. That's it, boys. That's it for today. Let's put on the next one. Oh, yeah, another difficult one. That's okay. Let's do this tomorrow. All right. I'll see you guys tomorrow. Adios.